So hi everyone, thanks so much for coming. We appreciate your being here. I want to say happy Thanksgiving to all of our American friends, and we appreciate your being able to make it on a holiday, and we are sorry that it's scheduled on a holiday. That said, this is a 4-part series, so this is the first of 4 tutorials or webinars that we're going to do, and the other ones are not scheduled on holidays. Every Thursday at 1 p.m. Eastern, you can join us and we'll get progressively more techy. Today we're going to give you a bit of an introduction to SensorThings. Next week, we'll go into the data model. The following week, we'll get into how you can connect and manage your sensors. And then finally, on the last week, December 17th, we'll get into querying and analytics with SensorThings. So Steve is going to be delivering these tutorials. As many of you already know, Steve is a professor of geomatics engineering at the University of Calgary. His career has been focused on SensorWeb and GeoSensorWeb specifically, and so he's going to be presenting to you on his expertise, and that is the OGC SensorThings API, the Internet of Things data exchange standard. So that said, I'll hand it off to Steve, and he will give you your presentation. Following that, we're very happy to take questions. You can ask us questions via the Q&A panel. And if you move your cursor to the bottom of the screen, you should see a Q&A that you can click on, and that's where it's best to ask questions. So go ahead, Steve.
Thank you. Is good? Hello. Okay, great. Thank you very much, Coral. And then thank you all for joining us today. So today, I'm going to talk about OGC SensorThings API. So today, just the introduction. And I think we'll talk for about 20 minutes. And then please feel free to ask questions if you have any using your Q&A panel. Okay, great. So this is the agenda. So first, introduction to Internet of Things and the SensorWeb. And then we'll introduce what is SensorThings API and what are the benefits of SensorThings API. And finally, we'll talk about some case studies, some existing projects using SensorThings API to manage their sensors and assets. So about me, Crow gave a very good introduction, but I just want to let you know that I'm heavily involved in the international standards making for IoT and SensorWeb. So that including OGC, Open Geospatial Consortium, as well as the ITUT, which is the United Nations telecommunication standard body. I'm also involved in ISO, 2 working groups in ISO relates to Internet of Things and sensor networks. And about us, SensorUp, we consider us as a world leader in OGC, SensorWeb, and Internet of Things. We are leading several international IoT standards, and we developed the world's first OGC SensorThings API implementation. And we're proud members of Eclipse Open Source Foundation and the Open Geospatial Consortium. Okay, so I want you to think about something. If you just joined the webinar right now, so I want you to close your eyes and think about something. And I want you to think about something very weird. And I guarantee you, the thing in your mind, it will be connected to the internet. And people will use that to collect data and try to quantify some phenomenon and try to optimize their operation. And no matter what is the weird thing you have in mind, and it will be connected to the internet and to form the concept called the Internet of Things. I'm going to show you many examples. So hopefully I can convince you the Internet of Things is not just a buzz. It is really happening. And in fact, around you in our environment, there are already many, many sensors collecting data. And right now, we are not using them. We're not using them. And there are many reasons we're not using them. And this is one of the reasons we developed OGC, SensorThings API, allow you to unleash the potential of your sensor data. I'm going to give you some example about some things. This is one thing, actually, just convince you IoT is really coming. So this is a sensor. You can buy it online. It's $29, and there are 10 sensors in this small package. It can last for 1 year if you collect data and upload to the the internet every second. So every second sampling rate, and for 1 year. And it's really allow you to quantify, to collect data about your environment. The sensors including light, 2 temperature sensors, the movement, magnetic sensors. There's even a button, and you can program them. $29. This is shirt, smart shirt. So your shirt are connected to the internet. And this is Hexoskin, and you can buy it on bestbuy.ca actually. Your drinks, even your drinks are connected to the internet. This from a company called Vessel. It costs about $79. They can tell you are drinking a Coke or a Pepsi. If you need to drink more water, it tells you. Your parking, it's a company, startup company. I think it's French company. It's called Fiber. San Francisco installed Fiber in their parking lot, parking spaces, so they can know the availability of parking, and then they can do on-demand pricing and using the price and to do the load balancing of the parking space. Because when the price going up, and then the less people will drive into downtown, and as a result, there are more parking space available. If the price there are not so many cars in downtown, for example, parking, and they lower down the price, and then more people can drive. Your baby, I just have a baby born, and today is 14 days old, and this is a sensor for baby. It tells you what the baby, the temperature, the movement, and then you just quantify your baby so you can understand your baby better. Your cat poop, even your cat poop is connected to internet. And for some people, pet are their baby, right? So it allows you to know the health status of your pet. Your inhaler is a case of health. So if you use this inhaler, and it records your location and time, and upload to a cloud, and if you subscribe to the service, and it tells you, okay, for example, the North San Francisco, a lot of people are using inhaler, so air quality might have some issues, and you might not want to go there, right? Another example about quantify, and then you can optimize. Even cows, this is called moo call, and actually if you Google Internet of Cows, you get a lot of players and try to innovate in this space. There are many cow sensors that out there, and to improve the cow health, and then also improve the productivity. Your light post. So if you work for the city, municipality, actually, every asset or infrastructure you have, it becomes an opportunity. You can sensor up and collect information for innovative applications. In this case, it's a light post. It is a great opportunity because it has power, it's everywhere, and you can install network on the light post. But for what? You can monitor air quality. If you have a sound sensor, and then you can monitor if there's anything happen. Like for example, we are working on pilot right now, and we are developing a sensor can be mounted on the light post. And if there's a major disaster happen, let's say accident, and the light post can pick up the sudden spike of the sound level, and then do a proactive dispatch. The light post call 911 for you, and then said something is wrong because it's very loud, and you might want to take a look at it. So the light posts work for you, and then this is a great opportunity actually for sensors and IoT. So hopefully I convince you actually everything, almost everything, will connect to internet, and then you can develop innovative applications. And here is a value chain of IoT. So let's say if you are interested, you want to develop an application for your sensors or your things, and these are the steps you need to go through. So the first step is you need to have a sensor, an actuator. For example, if you are collecting temperature data, you decide, okay, which temperature sensor I need to use, and what's the accuracy and the reliability. And then you need to connect your sensor into a smart device or a gateway. And this gateway has power, has more computing power, so that it can connect to the network. So sensor, gateway, and then finally, you need to connect to the network. The network can be a local network, can be a wide area network. But eventually the goal is to connect the local data and upload to the cloud through several levels of networks. And it could be Wi-Fi, could be Bluetooth, could be Zigbee, and eventually it hit the internet. So once the data hit the internet, you do need an API, application programming interface, for you to talk to the cloud or server. So that's the fourth step, device cloud API. So for the device to talk to the cloud. And finally, through the API, you enter your data into the cloud. Data management and analytics. Stored data in the cloud is not enough. You want people to use your data. And so the next step is a cloud application cloud API. So allow the web applications, sometimes there are devices as well, and to be able to talk to the cloud. So that's the sixth step, the application cloud API. And finally, with the application cloud API, you are able to integrate the different sensors together and develop innovative applications. And finally, reach the customers. So 1 to 7, these are steps you need to go through in order to create IoT applications. And the orange box, actually, is the scope of the OGC SensorThings API. So the number 2 is the smart device. So it's allowed the device to know a way to talk to the cloud. And 4, 5, 6 steps, actually, that's covered by OGC SensorThings API. And because it's the cloud API, so you can, right now, actually, if you want to develop an application for IoT, you have 2 choices. One is you develop your own API, your own data model, and your own way how you communicate with the sensors, and your own way communicate with the application developer. Or you can use some standards like the SensorThings API. And 4, 5, 6, the interfaces and data model is covered by the SensorThings API. And finally, step 7, that means there's client-side libraries, so help the developers to talk to the cloud. So that's the scope of SensorThings API. Okay, so here's a slide about what is SensorThings API. First, it's an open Geospatial Consortium standard. It's currently a candidate, and it will be voted. Adoption vote is scheduled next week, actually. So starting next week, and 3 weeks later, hopefully it become a real standard. And it's part of a mature and comprehensive existing standard. So it is new, but also not new. It's built on a proven working standard, has been adopted by many, many organizations for many, many large-scale sensor networks. So SensorThings API is a proven working standard. And it provides the following functions. First one, it provides you sensor data management, allow you to manage your sensor data in the cloud. Second, allow you to do some analysis, so sensor data analytics. So actually, SensorThings API provides very powerful analytics capabilities in one coherent API. And then SensorThings API allow you to command and control your actuators. So that's the tasking profile. And it's the next version of SensorThings API will have that. And finally, it can also do event detection and notification. That means you can program your sensor through SensorThings API and say, if the temperature is changing to, for example, over 20 degrees, send me a notification. So notification will be pushed to you. So it's a rules engine profile. Let's dive into more details. So there are 2 components for SensorThings API. The first one is a standard data model based on the ISO/OGC, observation and measurement. That's an international standard to describe any kind of sensor data observations. So with the standard data model, every applications and devices, they are able to understand the messages exchanged between them. And the second part is the interface standard. So that's the API RESTful interface standard to access sensor data, to task actuators, and detect events. And combine these 2 together, that's the OGC SensorThings API standard. And in between, if you look at the in between here, you can see these are the standard communication standards that SensorThings API can support. So SensorThings API support MQTT. That's a very popular standard from Oasis for IoT devices. It's very, very power efficient. And we also support HTTP as well as CoAP. CoAP is a new standard similar to HTTP, but designed specifically for Internet of Things devices. So SensorThings API is very, very efficient. And these are the benefits of SensorThings API. First of all, it gives you one coherent API and data model, integrate all your sensors. If you have many, many different kinds of sensor, or in the future, your system might need to add different kinds of sensor into your system. If you use SensorThings API, you don't have to worry about it cannot support those sensors because it's based on a very comprehensive open standard. So it's future-proof and extensible. As a result, because future-proof, so it's lower financial and technical risk because your investment will not be wasted. And it also lower the training cost and improve your productivity. And by the way, if you follow our webinar, and you will learn that SensorThings API provides you great developer experience. It is very, very easy to use, yet powerful. Next one, the benefit is open standard. It's based on OGC and ISO. So it's less chance to be locked in by a specific technology or vendor. Because right now, if you choose a technology provider, actually, you do need to worry about the lock-in. What if they're out of business? What if they switch their focus? What if? But if you use some standard, open standard, if you don't like this provider, you can change easily. So it's easier for systems from different parties and using different technology, and you can interoperate and communicate with one another. There's a benefit of open standard. And also, protect your investment because no lock-in, your system won't become obsolete soon. And also more choices available in the market. You could choose closed source. You could choose open source. You can choose a hosted solution like a SaaS, software as a service, and the choice is yours. Next one. OGC SensorThings API is location intelligent. Well, OGC, of course, Open Geospatial Consortium. So we're good at locations. So it's designed for both simple and complex geospatial applications. Indoor, outdoor, geometry, network, stationary, so the fixed sensors or moving features. And actually, if your application is an indoor application, and actually support indoor location. And it's based on open standard. Again, you leverage the R&D effort of the community. And second is it's designed for real-time applications. So it's great for fleet management, so moving trucks, asset tracking, anything moving, and then disaster response as well. I will show you a case study later about how this SensorThings API for disaster management. And also, SensorThings API is designed for both in situ and remote sensors like drones. So it can easily integrate a drone, which is a flying and moving sensor, with the ground sensor. Also, by using the API, SensorThings API, reduce your time to market. You innovate based on world-class R&D efforts. And so that's basically two choices. You do it by yourself, and then you need to learn your lesson, or you build your application based on existing world-class effort. And also, because it's an open standard, so you can leverage existing libraries, SDKs, developer documentations, developer training, knowledge bases, etc. So think about it. When you build your system, and then it's not only the code, you also need to have the ecosystem, libraries, for different technologies like Java, Python, so on and so forth. Develop documentations. So you need to have that. And then version 1.1, 1.2, 1.3. That's a lot of work. And developer training materials. By using open standard, you join an open community, and you work together, leverage each other. And also, the other benefit is reduce your development and maintenance cost. You can, use the more than 10 years R&D effort from OGC. And also, there's no need to build and maintain your own developer ecosystem. We build it together as a community. Okay, so these are the benefits of SensorThings API. Hopefully, you find them useful. And then, so I think lots of you might be asking, okay, SensorThings API is a new standard, so how mature it is? So here are the status right now. So adoption votes scheduled in December 2015. So it will become an official standard very, very soon. Although it's a new standard, it already has a compliance test available. So actually, this is one important thing. With a standard, using a standard actually is not enough, because in order to ensure the interoperability or the how are you doing the right thing or not, you do need a compliance test. And it's one indicator about how mature is a standard. And actually, SensorThings API, we already have a compliance test available to test different modules can lay interoperate with each other. And we have very complete SDK ecosystem, software development kit. We have Java, .NET, Python, Ruby on Rails, jQuery, Ember, Angular, Cordova, JSON, curl, you name it. It's a very, very complete ecosystem. And actually, lots of them are open source. And regarding servers, there are already at least 4 different server implementations out there. And we expect much more in the future. And also, you might ask, is anybody using it? Actually, there are large-scale projects using it. For example, right now, OGC has a pilot project. It's called Incident Management Information Sharing Pilot. And if you're familiar with the OGC procedure, actually pilot is it's a very mature technology and standard and demonstration. So demonstrate mature technologies. And this pilot is sponsored by Department of Homeland Security and IGES. So this is for some mission critical applications. So I would say, although it's a new standard, because it's based on a mature standard suite, and it's very mature, and it's proven working. So for the GIS people, these are the, I know you have these questions. So these slides designed for you, actually. First, is SensorThings API part of the OGC SensorWeb enablement? A lot of people ask us this question. The answer is yes, it is. Is SensorThings API compatible with the OGC Sensor Observation Service? Actually, the answer is yes, it's compatible. And actually, our implementation already support SOS. So the SensorThings API become SOS instantly. The third one, is SensorThings API compatible with Spatial Data Infrastructure, SDIs? The answer is yes, it's compatible. And lastly, can I use my existing GIS to connect to SensorThings API services? The answer is yes. So this is a great thing, actually, because by using SensorThings API, you can leverage your existing GIS infrastructure investment. And it's plug and play. It plays with your GIS infrastructure very, very nicely. And for example, we have an ArcGIS plugin available. If you're interested, you can contact us. So I'm going to present some case studies. This is the first one. It's for emergency management. So here's the problem. Right now, whenever there's a disaster or emergency, so the first responder groups, different groups, they need to go to the scene. And then in the future, or even right now, they do have lots of sensors with them. However, they use different systems, different protocols, and it's very difficult to share the data. And for the disaster manager, for decision makers, all they want to see is a coherent picture about what's happening. They don't want to see, for example, if there are 10 groups there, they don't want to see 10 screens. They want one big screen with 10 systems and the data in one screen in a coherent picture. However, this is not the case right now. So this is a pilot project, OGC pilot project for incident management, information sharing. So that means you have different systems, but through the open standard, including OGC SensorThings API, we play a critical role in this pilot, and we can form a system of systems. So the system boundary is gone. All you look at them is the data and analysis. So this is just to summarize. Sensors will be everywhere. However, it's lacking a common operating picture. And the solutions we provide from the SensorThings API is allow different groups accessing different IoT-based sensing with a coherent platform. And it enables interoperability. And the result, reduce implementation and training time and cost significantly in the future. And you know what? If you in the future, actually very soon, we will publish the demo videos, and it's just very impressive to see you have one GIS client, and whenever a new sensor joins the system, it pop up in one screen, and then they move around in real time, and they are from different servers, but you don't even feel, you don't know they are from different servers. It's just one coherent picture. This is really, really nice, and it saves lives. Next one, environmental monitoring. Actually, we already have many, many sensors for environmental monitoring. However, they are silo systems, and in Alberta, this is one big issue for us. And then, so SensorThings API can play a critical role to integrate these different sensors together and into a coherent picture, so that we can innovate without worrying the different protocol, without worrying the different data format. So this is one example. We work with University of Calgary and the Rocky View County. And the opportunity here is this, as follows. Sensors are become affordable. So it allowing citizens, in this case, the groundwater well owners, they can contribute to the groundwater monitoring. However, in this case, it's lacking a sensor data management platform to integrate data from more than 40 well owners. And before they use our technology, it's a very preliminary data management system. It's called Excel, or even fax, or even the SMS, short messages. So this is how they upload the data. And the researchers manually put them into the Excel file. And so it's difficult to share, difficult to analyze, and time-consuming to integrate them. And our solution allows citizens to contribute to their monitoring system effortlessly. It's very, very easy to use. And the various groups, they can access the groundwater data with a coherent platform. And even better, actually the most importantly, is it's a cheaper and better environmental monitoring. And it can be integrated with any other OGC system instantly. And just like the previous example, there are different systems. By following the standard, they become one system when you need to integrate them. And this is the same thing here. It can integrate into a global Earth observation system instantly. So this is one great benefit. So if you want to learn more, and we provide developer documentations, which is a translation from the OGC specification document into a more developer-friendly, with a lot of examples, code examples. So if you're a developer, feel free to go there and learn. And also, we have a community site, OGC SensorThings Week, standard working group community site. You can find the updates, activity about SensorThings over there. And the other good resource is read our technical blog. We do write and publish about best practices or some problems, some new innovations about SensorThings. For example, I just wrote a blog about Amazon IoT and AWS IoT and SensorThings. And actually, these two technologies complement each other very, very nicely. And of course, one of the best things to learn is attend our webinars. And we will have a series of webinars. And right now we are introduction series. But in the future, we'll have a more in-depth series. For example, how to use SensorThings for asset tracking, how to use SensorThings for environmental monitoring, what's the best practice, or how to integrate SensorThings into your spatial data infrastructure and your GIS. So stay tuned. Oops, I accidentally clicked that. Let me go back to my presentation. Okay. Any questions? So it's time for questions. No, you guys are very quiet.
While we're waiting for questions, guys, I just want to let you know that we are recording these, and we're going to make the recordings available on our blog so that there's a permanent link to them. So I'll put the link to the recordings in the webinar chat. You can find that by putting your cursor at the bottom of the screen and clicking chat. And I'll go back to Steve so that he can answer this the question that just came in.
Okay, thank you. The first question is, can you give an example of sensor observation service interoperate with SensorThings? Okay, so this is a little bit technical details, but I assume you know the You know SOS, right? Okay. So first, both SOS and SensorThings is based on the ISO OGC observation measurement. So the data model itself is compatible. So as a result, it's very easy for SensorThings. We can become a SOS. And we do have an example that you can use SensorThings through one URL, and then you just send this URL and with SOS request, and it becomes an SOS. And if you're interested, actually, we can email you the link and to see that. And the answer is because we are all both based on ONM, so they interoperate with each other very, very nicely. In more details, actually, the main difference between SOS and SensorThings is it's SensorThings is RESTful, and it's based on JSON. It's much more efficient. And SOS is based on XML and RPC, a remote procedure core way. So even if you see some SOS proprietary implementation, they have some RESTful interfaces. However, they are not RESTful. For example, for SOS, it's kind of complicated to insert observations, and it's not coherent. But for SensorThings, it's just using post to insert observations. That's it. So actually, I would say SensorThings cover most of the use cases by SOS, and they are both based on the same data model, so they interoperate. From SOS to SensorThings, it might be a little bit more difficult because there are some functions supported by SensorThings which is not in SOS. We will have a webinar in detail to talk about this. Hopefully, I answer your question. Okay, the next question is, let me repeat the question. So the success of the standard depends on decision from the connected device manufacturers to implement in their gateways. So how's the adoption right now? Actually, it's yes and no. Actually, in the process, we do talk to a lot of people, including device maker, including the cloud, including the applications. Actually, it would be nice if we go back to the value chain. Okay. So let me show the value chain. So adoption actually depends on the next page of value chain. Depends on sensor, device gateway, network operator, and also the application developers. And they all need to adopt the standard. And we talked to device maker. I think the trend right now for device and a gateway is they use a Oasis MQTT or other similar protocol like DDS. And so these are cloud standard agnostic because they want to work with the most cloud provider and APIs. So that's one example. Actually, they already support MQTT. And we support MQTT. So in fact, we play with this device very, very nicely. And also, these two standards, we complement each other. MQTT is a communication protocol, and most of devices, they will support the communication protocol, but that's the data semantics to be handled by the cloud. So we are a data interoperability standard, and we work with MQTT. So this is our strategy, or from our study, this is how the strategy to increase adoption and how it is going to work. And similarly to the other side, the application developers. And we just need to support all kinds of libraries, and we have to support them and to increase the adoption. Hopefully, I answer your question. Yes. The next question, is location a common sensor function? Yes. Location is critical for any sensor. For example, when you collect an observation, if you don't know the location of that observation, and that reading is useless. Let's say I had collected observation 15 degrees Celsius. Without location, it's not very useful. And in some cases, the location information can become complicated. We will cover that in the future webinar. For example, if you have a drone, So the location of the drone and the location of the reading, the observation, are different. The drone is in the air. However, when the drone is looking at the ground, the observation is the ground, the coverage of the drone's camera. So in order to process the information correctly and make them useful, both location information are critical. This is one complicated use cases, but the other example is fleet management. You have a truck, and there are like many sensors on a truck, and the trucks are moving, and you do need to have the location of the sensor. Yeah, no matter it's indoor or outdoor, they are critical. Any other question? Let me read. Yes, I agree. Actually, the feedback is, if location is not built in, then it's a problem. I totally agree. So when you choose a IoT API, choose one which support location. And actually, a lot of IoT proprietary APIs out there, and they have very naive support of location. Yeah, it's not gonna. Okay, we'll have more webinars about that to compare the different location models in different APIs. Okay, any other questions? If not, I would like to thank your patience and join us. Oh, there is one. Okay, this is important. So there's a question. What would you say, actually, are there competing standards? My answer is yes and no. First, define standard. If you are talking about open standard and from the standard development organizations, SDOs, and I would say the different standards from different SDOs, they complement each other rather than compete with each other. For example, we use MQTT. MQTT is the OASIS standard, okay? And then for location standard, it's OGC's world. And different SDOs, we try to work with each other rather than compete with each other. So actually, when you build the Internet of Things application, I would say this is based on layers of standards. But if you look at industrial consortiums, which is not open standard, they are not open standards, right? They are not governed by the open standard organizations like W3C, OASIS, IETF, or OGC, and they compete with each other. So typical is the beta VHS, right? They all claim they are standards, but actually they are not standard, right? They are the industrial standards and not the open standard, and they do compete. And we see a lot of activities over there, and like OIC, IIC, lots of them, all sing, all join, they do compete with each other. So you do need to differentiate between the open standards or they are just industrial specification. And in the open standard world, they normally don't compete, they complement. Okay. Okay, so thank you very much. And then finally, please come back next Thursday. We have introduced the data model of SensorThings, and we are going to release a playground. It's an online interactive tutorial of SensorThings. And then next week, we will share the link with you. It's a very user-friendly, very interactive tutorial, and hopefully you will like it. And so stay tuned, and we'll see you next week. Thank you. And if you are from the States, happy Thanksgiving, and we appreciate that you join us during the family holiday. But that means you really love IoT. Okay, thank you very much. Bye.